Hello, you're welcome. Today we're going to find this improper integral. The integral from 0 to infinity of the natural log of x divided by x squared plus 13, and then we have our dx. So let's see how we're going to solve this problem. Here, let's call this integral I. Now, this is what we're going to do. I is same as the integral from 0 to infinity. The natural log of x, then divided by, at the denominator here, let's factor out 13. So when you factor out 13, we're going to have x squared divided by 13, and then plus 1 dx. Now, the 1 over 13, bring it outside, we have 1 divided by 13, then multiply by the integral from 0 to infinity. So here we have 1 divided by, so x squared over 13, we know we have x squared. 13 is same as root of 13 whole squared. And then we have our plus 1 and dx. Okay, take note of this. When you have a raised to the power of m divided by b raised to the power of m, since they have the same power, it will be a divided by b whole raised to the power of m. So therefore, our I is going to be equal to 1 by 13, the integral from 0 to infinity. This is 1. Is that 1? Oh, sorry for this. I misplaced something. So this is natural log of x, actually. So we have natural log of x, then divided by, then this place, this is going to be x divided by root of 13 whole squared, and then plus 1. Then we have our dx. So let's make the following substitution. We're going to let x divided by root of 13 equals t. When you cross multiply, we see x is equal to root of 13 multiplied by t. Differentiate both sides, we get dx is equal to root of 13 dt. With this substitution, our I is going to be equal to 1 by 13 multiplied with the integral from 0. Is that from 0? Check it out. If x is approaching 0, t will be approaching 0 divided by root 13, which is 0. When x is approaching infinity, t will be approaching infinity divided by root of 13, which is infinity. So we have infinity here. Then the natural log of x will become the natural log of root of 13 multiplied by t. Then divided by, this here is going to be t squared, and then plus 1. Then our dx is the root of 13 dt. So from here, our I is going to be equal to, this is root of 13 divided by 13 outside, then integral from 0 to infinity. Up here, with the property of logarithm, it will become natural log of root of 13 plus the natural log of t, then divided by t squared plus 1, and don't forget our dt. Now it is time to split the denominator and evaluate the two different integrals differently. So here we have I is equal to, this will be root of 13 divided by 13, multiplied by the integral from 0 to infinity. We have the natural log of root of 13 divided by t squared plus 1 dt, and then plus, this is root of 13 by 13, multiplied by the integral from 0 to infinity, the natural log of t divided by, this is t squared plus 1, and then dt. But let me tell you guys, this integral here equals 0. But in this video, we're going to prove that, okay? So now, let's call this integral here a sub 1, and this one here a sub 2, which is equal to 0. So for my a sub 1, this is equal to, this will be root of 13, natural log of root of 13, whole divided by 13, multiplied by the integral from 0 to infinity. We have 1 divided by t squared plus 1 dt. So this is going to be equal to root of 13. Now natural log of root of 13, remember the 13 has a power of 1 over 2, so it's going to be 1 over 2 natural log of 13 whole divided by 13. This is the inverse tangent of t, right? From 0 to infinity. So a sub 1 is going to be equal to, this will become root of 13 natural log of 13 divided by 2 times 13, that is giving us 26. Then we have to put the upper limit, the inverse tangent of infinity minus then the lower limit, the inverse tangent of 0. So the inverse tangent of infinity is pi by 2 and 0 is 0, right? So we're going to have root of 13 multiplied by the natural log of 13 whole divided by 26 times 2 is giving us 52. Don't forget our pi. Oh, that's cool. Don't forget that, please. So remember we have pi. Okay, but this here is the final answer to the integral, okay? But let us go back and prove that a sub 2 is equal to 0. And that will make this to be our correct answer. So we have to prove that a sub 2 is equal to 0, and a sub 2 is equal to the integral from 0 to infinity, the natural log of t divided by t squared plus 1, and then the t. Now there is a substitution we're going to make here, which is going to treat this integral nicely. So we're going to let t equals 1 by x. Differentiate both sides, so get dt is going to be equal to negative 1 by x squared dx. If you think about our limits of integration, you're going to say when t is approaching 0, remember that if it's solved for, okay? Yeah, if t is approaching 0, remember if you solve for x here, x is also equal to 1 over t. So if t is approaching 0, x is approaching 1 all over 0, which is giving us infinity. If t is approaching infinity, x is approaching 1 over infinity, which tends to 0. And here we have the natural log of t, which is 1 over x. Then divided by t squared is going to be 1 over x squared. Don't forget our 1. And then multiply by negative 1 by x squared, and then dx. Now let us recall the following. We know that the integral from b to a of this function of x dx, that this is equal to negative integral. Then from a to b, you switch the limits of integration of that same function of x dx. So our a sub 2 is going to be equal to, when you switch the limit running from 0 to infinity, then the negative sign at the dx side is going to cancel, right? And natural log of 1 over x is same as negative natural log of x, right? Then divided by this right over here is 1 over x squared plus 1. Don't forget we have dx multiplied by all over x squared, I mean. So remember we're opening this bracket with x squared, so something really cool is going to happen. So this is going to be the integral, the negative integral from 0 to infinity. We just have natural log of x divided by, this is just x squared plus 1, and then dx. Okay, so here you can see clearly that a sub 2 is equal to negative a sub 2. Add a sub 2 to both sides, we get 2a sub 2 is equal to 0. Now divide both sides by 2, we see that a sub 2 is clearly equal to 0. This is indeed cool. Therefore, we come to our conclusion that the integral from 0 to infinity of the natural log of x divided by x squared plus 13 dx is equal to pi root of 13 multiplied by the natural log of 13 or divided by 52. And this right over here is approximately equal to 0.558 723. Am I getting it? 579 and this is our solution in exact form, and this is our solution in approximate form. Thank you for watching. Please, if you really enjoyed the video, do wait to subscribe to this channel. Also like, comment and share.